webinar series. So I encourage every participant here to open your camera and use the virtual background that will be sent by my colleague in the chat box. Okay, so today our topic today will be discussing about exploring the perspectives and prosthetics and orthotic postgraduate research in Malaysia, past and present experiences and insights for the future. Our speaker today will be from University Malaya, Malaysia. So for all of you for participants who haven't joined our even before, let me introduce our project. So the International Perspective webinar series is a series of international online knowledge lectures jointly led by the CMUTAD and then China ASEAN Technical Education Cooperation and co-hosted by International Youth Culture and Education, or KEMG, and also Go Study Global Education. So our program is expected to invite 1 until 2 school faculty members to give webinars each month, aiming to enhance and enrich the growth of knowledge and broaden the horizons of learners in the Southeast Asian region by inviting experts from different countries and fields to provide high quality and universalizable online lectures that will help learners to acquire specialized knowledge through knowledge sharing and cross-cultural understanding. Okay. Has joined us today, Dr. Nasrul Anwar. Are you here with me, Dr. Nas?
Yes, I'm here.
Welcome to our event. So, Insinyur Dr. Nasrul Anwar Abdul Arazak will be our speaker today. He is currently serving as the Deputy Dean of Faculty Engineering, University Malaya, and then he also served as Executive Board of International Society of Prosthetics and Orthotics. And he also an expatriate panel at Unit Bersepadu Kementerian Kesehatan Malaysia, or Malaysian Minister of Health, and he do a lot of research and articles about prosthetics and orthotics engineering, biomechanics, biomedical engineering, rehabilitation engineering, assistive and rehabilitation robotics, and also disability innovation and inclusion. So I believe that our session today will be very insightful and will be very fun. So yeah, Dr. Nasrul, can you, okay, I think, okay, Dr. Nasrul, okay.
Yes.
Yeah, you can do the screen sharing now, and time and screen is yours.
All right. Okay. Thank you so much, Rifda. Assalamualaikum warahmatullahi wabarakatuh, and a very good day and also good afternoon to each and every one of you. So let me share my screen first. Okay. All right. Is everything good? Okay.
Yes, everything good.
All right. Okay. So basically, just like what Rifda mentioned just now. So my name is Nasrul Anwar Abdul Razak. I'm from University of Malaya, Kuala Lumpur, Malaysia. And right now, I'm a holder position of a Deputy Dean of the Faculty of Engineering. I was made to understand that each and every one of you come with a multidisciplinary background. So basically, I try my best to make sure whatever I explain, whatever technical things that I'm about to share, somehow relate with whatever you are doing, and etc. All right. So because here at the Faculty of Engineering in University Malaya, we are actually the top ranking university in Malaysia. We are right now at the 68, 58 of the world ranking universities as a research university. Apart from that as well, I am the ISPO Executive Board. ISPO stand for International Society for Prosthetics and Orthotics. All right. So for those who didn't know about what is the prosthetics and orthotic terms, later on I'm going to explain further. And also I'm working with the Ministry of Health expatriate, meaning I among the committee that somehow checking, validate those who is a foreigner would like to working here in Malaysia as an expatriate in the field of prosthetics and orthotics. So prosthetics and orthotics is actually closely with the rehabilitation engineering. All right. So these are my details, and I'm also leader of the Center for Prosthetics and Orthotic Engineering, center of research which is actually based in University Malaya. If it happen that you are able to visit Kuala Lumpur, visit Malaysia, just give me an email or text me using WhatsApp. Of course, you can able to come to my facilities and visit my laboratory, especially. All right. So today we're going to talk about the exploring the perspective of a prosthetics and orthotic postgraduate research in Malaysia. All right. Talking about my own experience from the past, presence, and also the insight for the incoming future. The outline will be divided into a three portion. The first one will be on the historical background, the opportunity for postgraduate studies, what do and don'ts, what are the requirements, what could be the qualification needed here to study in Malaysia, and then my own research team, what we had conduct so far, and then what could be the future direction for prosthetics and orthotics throughout that, not just for Malaysia, but of course for the Southeast Asia as well, and of course including the world as well. All right. Uh, all right. So a bit brief about University of Malaya. All right. So I believe that from 10 country in the Southeast Asia, not everyone able to visit Kuala Lumpur, not able to come to Malaysia yet, but this is how the map of Malaysia look like. So we are really at the city center of Kuala Lumpur. The map over there is the University of Malaya campus map. We have a lake, we have a green, we have a hill, we have around 22 different faculty that might interest you as well. So at the Faculty of Engineering, we have our own mission and also our own vision. So our vision is actually to become the center of engineering excellence that will bring the impacting to the world. And our mission will be pushing the boundaries of knowledge, nurturing aspiring leaders, and fostering strategic partnership with the industries. For those who didn't know, actually, University Malaya, Malaysia, we have right now 10 prime ministers. 6 of our prime minister is actually come from University of Malaya. So 6 out of 10 from our current prime minister is actually graduate from University Malaya. So that's why we are having this habit that is producing or nurturing aspiring leaders. Most of our graduate finish the schools from University Malaya. They are CEOs, they are main directors, board of directors, prime ministers, and etc., working in the industries, working in the government sectors. All right. Okay, so we have a lot of industrial partners as well, because we are engineering based. So most of our program, most of our teaching subject is actually collaborates with people from the industries. For example, in one semester, we have 14 weeks of a lecture, usually around 1/3 of it around industry. So these are among the list of a company of an industry that involved with our teaching. Someone may say no about the Motorola, Philips, Daikin, Panasonic, and then of course Standard, etc., and of course Microbe and also Cerium as well. So these are among the company that is actually involved in our teaching. Our undergraduate program, which is actually 4 years of a degree program, throughout the 4 years. During the third year, we have a lot of industrial attachment, meaning like in the third year, you barely come to attend the physical class, but it will be more to like a virtual class, because you are attached at the industry. You go to the industry, sorry, but at the late evening, you will continue listen to the lecture. Okay. At the Faculty of Engineering, here, it's a chemical engineering. The second one is electrical engineering. The third one is a civil engineering. The fourth one is a mechanical engineering. And the fifth one is a biomedical engineering. For those who didn't know, a basic like electrical engineering is the one that dealing with electrical electronics components. So this is a wide-verse field, worldwide needed field of engineering by each and every country. Second famous program is actually mechanical engineering, where people study about the structure, mechanical joint, automotive, aerospace, automation, etc. And then we are talking about the civil engineering, where it's about the structure of a building, static, dynamic, and etc. And then we have a chemical engineering, where you're dealing with the chemical reagent, you're dealing with the chemical atom, etc. Same like when we in the school, we learn about the chemical, we learn about the physical, atomic, and etc. And the last one that fall interest is actually the biomedical engineering, among the interest field that I would like to share today. So in biomedical engineering, it's actually a combination of all 4 different types of engineering to become one field, which is known as a biomedical engineering. By taking biomedical engineering, you need to somehow know a basic knowledge of electrical engineering, mechanical engineering, civil engineering, and also a chemical engineering. That's why we have a really high demand in terms of a biomedical engineering here in Malaysia. And also, field of a biomedical engineering is something that is a never have an end. People are looking to look younger every day. People are looking to have a more health in a healthy way every day. People would like to have a more good health condition every day. So everything is involved with biomedical engineering. These are the situation at our university. So for undergraduate students, 93.2% is our local students and 6.8% is our international student. So in 1 year, we have around 1,777 undergraduate students at our schools. For postgraduate students, we have 832 enrolled average every year. While we have a more international student who is doing their postgraduate studies with us. Please excuse me. All right. You can see from here the international postgraduate enrollment. You can check from here your country, how they are interested with our university. At the moment, we have 5,762 international students, which is from a diverse background. I can see that there's a lot of people from Indonesia, around 224. We have people from Pakistan. Just now, it's around 178 study here right now in Malaysia. We have India around 111. We have from Sri Lanka. We have from Thailand. We have from Brunei. Myanmar, we have 7. We have Vietnam around 5. And of course, we are looking forward people from Philippines also have a 7 with us right now. So these are the breakdown of our international student condition at this moment. Talking about the global partners, so these are the breakdown where our international hub at work so far. So we have collaborators coming from each and every mentioned flag over here. Not just related to the teaching, but as well in terms of research. Now, when we talk about the biomedical engineering, usually when we deal with a human being, we conduct the development at the university, and then we bring the trial, the process at each and respective country. For example, someone mentioned he's from Pakistan just now. So we have a collaborators from Pakistan known as a PIPOS, Pakistan International Prosthetic and Orthotic Schools. I think it's in Islamabad, if I'm not mistaken. And then we have Jakarta School Prosthetics and Orthotics. We have Philippine Schools of Prosthetics and Orthotics as well, under the UERM. And then we have Sinindron School of Prosthetics Orthotics under the Mahidol University. So these are our global partners where we keep on collaborates, communicates in terms of integrating our curriculum and also come out with a proper research, etc. for the benefit of a Southeast Asian. All right, so these are the facilities that we have at our university, among the classes set up and also the computer labs that we have here at Faculty of Engineering, University Malaya. Full view of a class, colored class, and etc. The reason why we colored it with a different kind of color to make sure it is bring more proper environment with the generation nowadays. All right, so these are the new look of the teaching class nowadays. We have couples of labs, all right? So these are among the labs that I would like to share today. This lab known as a Vicon motion analysis. Okay, you can see one guy over there is doing some movement, and then we are checking his movement. All right, so you can see the figure from there. It's like a similar technology that we use in the CGI. All right, so these are known as a Vicon motion analysis. When you conduct a movement, like for example, jumping, walking, and etc., we are checking every moment. When you step down on the force plate, and etc., we will measure whatever the force you've been given to the ground, and then we will calculate it again. From there, we know that you are working in the proper way or not. And then these are some of the development that we have conduct here at the University Malaya as well. So you can see as simple as putting a sensor inside the socket, and as well make sure that he are able to use it in climbing stairs and etc. Okay, so like I mentioned just now, two terms that you should know: prosthetics and also orthotics. Prosthetics is actually replacing the prosthetic limb, while orthotics is actually supporting whatever limb that you still have. Okay, so it's a two different kind of things. In Malaysia, the highest condition for prosthetics needed is really high, not because of a natural disaster, not because of the environment, but because of the health issue, which is a diabetes. Diabetic is the most high cases that have made people need to wear prosthetic here in Malaysia. Compared to some other countries, like for example, Japan, they have a natural disaster, they have an earthquake, they have a tsunami, but we don't have this kind of a natural disaster in Malaysia. That's why our really biggest influence cause of amputation is actually diabetes. I know some of the country from your side, for example, in Cambodia, Phnom Penh, you still have a cause of amputation coming from the civil war that have a few years back. That's why we see a lot of people being affected by the landmine in Cambodia, and people are still in the process of improving and helping, providing a proper prosthetic legs to the community in Cambodia. In Jakarta, for example, as well, if there is a tsunami and also um, earthquake, for example, in Bali, might have somehow increased the number of people need for the prosthetic legs. So this is why the process of developing this kind of devices is still happen and keep on upgrade from time to time. You can see what we try to implement here at University Malaya. We try to design a new microcontroller, a new chip. So this chip is actually able to make sure that the legs, prosthetic legs, auto-intelligent. They're able to somehow communicate by themselves, know what they need to do by tapping a foot of a prosthetic legs. For example, this guy, he tapped in one or two sensor using a foot touch, and then the legs will know that he need to bend in order to climb a stairs. So these are the new way development of a prosthetic legs. All right. Now, like I said before, you are from a different background. Some of you could be from a philosophy. Some of you could be from a material background. Some of you could be from statistical background, economical background. Could be accountant, for example. So by taking the example of a prosthetic legs, try to imagine everything relate to your own field. Statistical, for example. So you might want to know right now what could be the average of the statistic amputation that you have at your own country. Number one. Number two, if you are from the statistical, no, you are from the economical accountant, for example. So you might want to study what kind of price range that your country have provide for these prosthetic legs, and what could be the comparison with other countries, Malaysia, Singapore, Indonesia. So why the price is different? Is it because of the taxes, or is it because of the imported item, etc.? If you are from the philosophy field, psychology field, you would like to make a survey checking about what could be the self initiative coming from the user in order rating the performance of using the prosthetics in annual daily life activities. For example, one guy is wearing prosthetic, so he want to evaluate himself. So as a physiotherapist or as a psychotherapist, you might want to discover what do and don'ts and what could be the process of achievement daily life activities. And if you are from a designer perspective, for example, you might want to relate this as well, how to improve the condition with your own country. Remember, although we are from Southeast Asian, but not everything we have share the common facilities. All right, it could be a different kind of a stairs that what you're using in Malaysia comparing to in your own country. These are some other examples of the lab that we have at University Malaya as well, mechanical and also a civil engineering lab. Okay, a bit more information. Just now, I already mentioned about 5 different undergraduate programs that we have here in Malaysia. But I believe that you have a more interest about the postgraduate program that we have here in Malaysia. Now, in Malaysia, we have University Malaya. We have a research mode and also the coursework mode. Okay, for the research mode, there's a two. First is a PhD in engineering science, and number two is a master in engineering science. Although the word is coming from the engineering, doesn't mean that you need to graduate from a bachelor degree of engineering. Okay, as long as you have a science-related basis, there is an eligibility for you to apply for masters in engineering science or PhD in engineering science. All right. So, what will be the requirement for the master in engineering science to graduate? For masters in engineering science, you are able to graduate minimum in 1 year and maximum in 5 years. Okay, depends on your performance. If you are able to publish one publication in the duration of 1 year, there could be a possibility for you to have a master's in engineering science within just 1 year. All right, because it's a full of research. If you are able to make a publication articles in 1 year within the duration of 1 year, there's a higher chances that you're able to graduate the program within just 1 year, complete, known as a master's in engineering science. All right. However, if there is a still need task for you to complete, you can keep on continue until the maximum of 5 years. For the PhD in engineering science, right, So the minimum to complete the PhD is just 2 years if you have a 2 publication. All right, if you have a 2 publication, and then there is a potential that you able to graduate as minimum as 2 years, or maximum will be 8 years. Okay, but usually people will complete it around 3 to 4 years. But if you are really outstanding, there is a higher chances that you will be complete within just 2 years. All right. So these are the conditions here in Malaysia, in University Malaya. And then, of course, apart from the full research mode, we have a 5 different kind of a coursework as well. We have a master's of this coursework is same like our bachelor degree, but the class will be during the weekend, usually full from 8 until 5 p.m. on Saturday and Sunday, because of usually people that register for the courses is doing it in a weekend basis because they are work in the weekdays basis. All right, the flight barrier about Malaysia, especially at University Malaya. So the 60 world ranking is 3 months ago. Okay, we already at the number 58 of the world ranking today. University ranking Asia, we are number 9. We are number 3 at the Southeast Asia. 66 of a world university ranking, and also Green Metric is currently number 50. So these are the graduation program study by coursework that I mentioned just now. The achievable of a final GPA 3.0, complete the numbers of credits, fulfill the program requirement, fulfill the basic language of a Bahasa Malaysia. Bahasa Malaysia is our own language here that we use in Malaysia. It's similar with Bahasa in Indonesia, Malay in Singapore as well, Brunei. I think some of the words that we share almost close with Thailand, Philippines, and Cambodia as well. Some of the words that we use is quite similar. So there shouldn't be a problem or difficulties if people from Southeast Asia and Asia would like to learn Bahasa. So this is what I mentioned just now. Masters by research, fulfill the Bahasa as well for the international candidates. You have a research methodology class, proposal defense class, candidature defense class. You must at least have 1 journal accepted in 1 year. Then you can finish in 1 year. For PhD, 2 ISI as well, publication within 2 years. Then you can finish in 2 years. There's a condition where you can convert your master's upgrade to become a PhD as well at University Malaya. If you're really outstanding throughout your master's, you already come out with a lot of a publication, there are higher chances that you can apply to convert your master's directly become a PhD with a certain requirement that you need to fulfill. For example, discuss further with your supervisors, etc. All right. Sorry. All right. Okay. Okay. Now let I go to the second piece about what I'm about to share today. All right. So just now is about the University Malaya. Whatever requirement, whatever needs, whatever things that you think interest you, you can study further. You can ask me further later on, or you can discover more throughout what could be the opportunity if you like to further your master's or your PhD here in Malaysia. For the second parts of the lecture, I will continue to share about some of our research that we conduct here at University Malaya. Okay, so our research known as the Center for Prosthetics and Orthotic Engineering, CPOE. I think I have an Instagram and also Facebook about this, but I'm not sure is it still active or no. So these are our team, all right? So you can see people, number 1, 2, 3, 4, 5. 5. The guy, 5 in the middle, without both hands, you can see. So he is actually part of our team as well, okay? So we are known as the Be Able. So Be Able is we share our experience, our facilities, our information, and we educate the people with disabilities. All right. So people with disabilities, not just people that wear wheelchair, but our focus will be people wearing prosthetics without hand, without legs, or even not able to work properly as well. So our Be Able is actually consists of an educator, engineer, science officer, assistant engineer, rehab expert, prosthetist, orthotist, and institution students, etc. Can you be part of a Be Able team? Yes, you can. No matter what kind of a field you are, there's an opportunity for you to be part of the team as well. Because what we are doing is something that is towards the human being, not about design of a car, not about design of a aeroplane, aerospace. No, we are helping human being using the engineering philosophy, engineering technical perspective. And of course, to design it, we need a more input. We need more team member, and we need more people like you. You are from your country, you should know your own situation in your own country. Statistic, people without legs, cause of amputation in your country. What are the needs for your countries? I didn't know because I stay in. Look around your side. What has been developed so far for the people with disabilities? What will be your key role as a secretaries? As people know about statistics, people know about law, people know about account, and also policy maker. Okay, so here we can help to build something new. Okay, all right. Let me share the experience of people from our team. The first guy, known as Mohammed Malahim, he is from Jordan. I forget which one is him. All right, on my left side, wearing a white shirt over there. Okay, so Malahim produced one article about a study of a transtibial prosthetics alignment procedure and their impact on lower limb kinematics in a clinical setting. Okay, now Malahim is from Jordan, working in Saudi Arabia. So he came to Malaysia. He discussed with me about he's having an experience of a clinical setting in Saudi Arabia. And then he want to compare the clinical setting in Saudi Arabia with other different countries. I said, okay. So he's comparing the clinical setting for a prosthetic fabrication process in Saudi Arabia, in Jordan, and also in Kuala Lumpur, Malaysia. Because you want to check what could be the environment. When you want to fabricate a prosthetic, what could be the environment or space that you need? What could be the how many staff do you need? What kind could be what could be the electricity? What could be the air condition? What could be the water temperature, etc. So this kind of a thing we study. Okay. The second guy on the left, on my right, on the picture, wearing a blue color shirt, known as Khalid Nadal Sok. He's from Palestine. So he developed a FSR sensor cuff to measure muscle activation during the strength and also gait cycle for lower limb. Right? Too scientific. Let me explain this. So when your muscle is cramping, okay, you don't know what could be the value. So you want to know the value. Why you want to know the value? Because imagine now, suddenly, okay, suddenly, na'uzubillah, you got amputated, okay? So, of course, you are without your legs anymore, okay? But you don't know how it's going to be felt, okay? And when you are no longer without any kind of a finger, so you need to have a proper sensor in order to make sure that you feel that, yes, you still have your finger in order to move a prosthetic finger later on. So that's why this Khalid Soft come out with a purely new design of a FSR sensor. So he provides this sensor in order to check the muscle condition, in order to provide the information to the robotic prosthetic legs or prosthetic hand to move later on. Okay, so these are the two person over here, and these two already complete their PhD. I think soon going to convocation, graduation ceremony at the end of this year. Sorry again. All right. The next person over here is Zainab Ghanodi from Iran. Okay, so Zainab is not from technical engineering. He's from chemical science. So he come to me and then we discuss about what could be related with his own field. I said, okay, Zainab, since you are from the chemical things, why don't you study about the improvement of the material that we use to fabricate the prosthetics? Why we need to improve the material, okay? Now you imagine you are wearing your shoes right now, right? So suddenly sometimes you feel like there's a pain because of the shoes, right? You got a skin irritation, you got pain, you got itchy, etc. because of the design of the shoes, because of your sweating, etc. because the activity that you are conducting in annual daily activities. So that is normal. What I mean is us with a proper legs and etc. What about those people with disabilities? Okay, they are wearing prosthetic legs. Okay, without knowing a proper size, without knowing what should they do, etc. They cannot integrate. They cannot influence the prosthetic legs to follow their order anymore because they no longer have a prosthetic fingers, etc. That's why Zainab come up with statistical analysis about the tension behavior, about the material that we use to fabricate a prosthetic legs. So from there, a bit of an improvement had been helped to somehow check the condition, to develop a new kind of a prosthetic socket using a new kind novelty of a materials. So the materials are able to auto adjust accordingly to the movement, to the size of the prosthetic user. Imagine like this: you are wearing a shoes size 7. Suddenly one day you wake up and then you felt like it's too tight. Okay, so of course these shoes not able to adjust by themselves. Now for prosthetic user, the socket itself, we call it as a socket, it can be auto adjust, needed from the size, because each and every day the size is changed in a 0.06%. Okay, so this is a, yeah, human body change 0.06% in 1 second. For example, right now you are listening to my lecture. 0.06% of your own body weight is actually changing. That's why sometimes when you try attire, pants, etc., you feel like, oh, this is a bit tight, this is a bit loose. Actually, because of our body change 0.06% plus minus in 1 second. So that's why sometimes we feel like, oh, this shoes is too tight. We go for 6.5. It's not 6, it's 6.5. Suddenly, when you go back home, oh no, it is too big. You want the 6 size. Because this kind of a thing, 0.06% change in 1 second. All right. The next study is about Ibtisam El Ghalazi from Morocco. Ibtisam study about EMG. EMG stands for electromyography. Electromyography stands for a sensor that you put at the muscles of your foot. Why? Ectism want to check what could be the condition of the muscles when people are walking at a certain distance. 1 meter, 2 meter, 3 meter, 4 meter. What could be the speed when he is walking, etc. So Ectisam put an EMG sensor at the foot in order to check what could be the performance. Because sometimes we felt like too tired walking in 1 kilometer, someone too tired walking in 1 meter, someone too tired walking in 10 kilometer. So this kind of thing, we need to have a proper data. Maybe at my age, okay, I can only walk around 5 kilometer, but all of you still young, you can walk until 10 kilometer. So we need to have a advisable data mentioning to us. Good morning, Dr. Nas. You can only walk 5 kilometer today. Tomorrow I wake up. Good morning, Dr. Nas. Today you are much more fat compared to yesterday. So please walk 6 kilometer today. Something like this, all right? And these are some of other students' title. Bin Sani from Cairo. He is designing about the EMG as well, sensor. But rather than putting at the foot, he studied about the elbow condition. So he put a sensor here in order to put the sensor over here, and to make it movement, etc. Movement, etc. All right. Mudawi Zaki Ali from Bahrain. He studied about the temperature and also the humidity monitoring system for the prosthetics and also orthotic workshop. So this kind of a thing actually for our students, he put a temperature sensor. See, it's not even related with prosthetic orthotics, but he used the environment in order to check the humidity of the environment. Okay. Abdullah Ibrahim Ahmed Abu Abed, Saudi Arabia. He studied about the myometry of a prosthetic hand. Myometry prosthetic hand, also known as a robotic hand. Okay, so this kind of a thing using sensors, etc. And another one from Syria. This one is study about the detective Omar Hassan Omar investigation of a sensor-equipped devices for shoe to checking the distance of a movement. So he is checking people are wearing a different kind of shoes to checking that it is working in a proper way or not. Sorry about that. All right. Okay. Sorry again about Omar Hassan Omar, kinetics and also kinematics of shoes performance. I give you one example. Sometimes when you are walking, all right, using a sandals, using a slippers, for example, after a few weeks, after a few months, suddenly the shape of the sandals, of the slippers is become no longer sharp, right? Because the grip is no longer there, okay? And then we are blaming because we are buying a cheaper kind of sandals, cheaper kinds of slippers. But basically, it is not because of the materials, but it's because of us, the way we are walking. Some of us walking in a proper gait. Some of us love to somehow when he is walking. Okay, you better check your foot condition. Whether you are having a flat foot, whether you having high arch. Flat foot meaning like your foot is totally flat. That's why you have a high tendency condition that your shoes is not in the well shape. You are still young. My advice is that try your best to use your sport shoes whenever you are go. Whether you are attending official ceremony, go to class, walking to the town, it is better to use a proper shoes, which is actually a sport shoes with a proper arch over there. Because by using this kind of shoes, it will help you to improve your gait. improving your gait is actually can save you a lot of a thing when you're getting older, 40 years and above. At my age, I felt like we having back pain, and we keep on blaming why, but it's actually because of when we are younger, we don't somehow apply this kind of a technique. Use a sport shoes so that it can help influence your backbone when you are getting older later on. Okay. All right. Apart from whatever my student had conduct research just now, I want to show you one of these figure that is actually interests me around 20 years ago. All right. Um, 20 years ago, when I was first try to figure out about my master's research and also my PhD research topics. All right. So I have been given this figure over here. Everyone know that this is a robotic hand. Okay, we've seen a lot in the movie. We've seen a lot in the Iron Man movie. We've seen a lot this with Cyborg movie, RoboCop movie. I'm not sure you know RoboCop or no, but of course you know Iron Man. So basically, this is a perfectly been designed mimicking a really natural human hand. From the finger, it can hold the ball without even breaking the ball. It's like when you are having an egg. Let me replace the ball with the egg. The egg will not be break, right? Because of the sensors of the fingers, right? And then the wrist, the elbow can 100% mimicking a natural human hand. Same goes to the elbow pipe. So when I was studying what I should design in the coming future, what could be the future interest one day, because every other parts already been discovered by other researcher, by other novelty scientific researcher. So I come out with the idea to improve the socket pipe, the one that attached to the to the shoulder over here. All right. Why? Because this is the most important part. Okay. It's like you are buying a shoes and you want to make sure that you like the shoes. Um, just an average, like people buy like you have like what two pair, three pair of shoes, but believe me, each and every one of us have their own favorite pair to wear everywhere they go, right? Same goes to the prosthetic as well, because you've been provide them with a one single prosthetics, but then they neglect to wear it. Why? Because of the socket pipe. It's not felt interest to them. It's not like a user friendly. It's not like it didn't feel comfort for them to wear. So that's why I come up with the idea on how to improve to design this prosthetic socket. So make sure that it is an auto adjustment accordingly to the size of a prosthetic user. Okay, because not everyone come with a static condition. When you are wearing a prosthetic, when you are wearing shoes, for example, your bones, your muscles is moving as well, right? So same goes to people that wearing prosthetic hand over here. So this is a prosthetic hand. Is putting over here. So whatever movement you conduct, okay, of course he will feel pain, skin irritation, a lot of things happen to him as well. So we need to make sure that he felt comfortable when he is wearing the prosthetic as well, right? So that's why my team come up with this kind of a thing known as automatic cuff. We put a proper sensor over there, and then it become a ring attached on, I mean, at here. So whenever the muscle is moving, and then, oh, okay, you cannot see. Can you see? Okay. So whenever the muscle is detecting, then it can help to improve the robotic hand as well. So this is known as automatic cuff sensor. Another examples of prosthetics hand is this one. So this is known as a 3D printing prosthetic hand. Okay, we've seen a lot, we've heard a lot. Jakarta, Phnom Penh, Vietnam, Brunei, Sri Lanka, India, Pakistan. Whenever you are, you know about the technology of a 3D printing. Okay. However, it is still at the really 10% surface of a developing from the perspective of a giving it to the user. Okay. Why? Okay, because of you cannot simply do a 3D printing and provide to the prosthetic user. What happens if you print a 3D printing of a prosthetic legs, for example, provide to someone suddenly got break prosthetic legs? What will happen to his life? It could be played around the policy, ethics, and etc. That's why I say, if you are backgrounds from policy, ethics, you're working with the government, etc. Try to look into these opportunities as well. Could be you can help to develop some standard guideline. Whoever want to do a 3D printing, there could be a standard procedure need to be followed. All right. Okay, just to mention about this 3D printing, we simply use a 3D scanner. So we scan whatever we have on the left, we print it, mirror it, and then it's going to print on the right side, something like that. All right, so the figure on the top there, the red color, is a scanner, and then we assemble it using a microcontroller, and then it come up like this. The color choosing depends on the material, but you can see the socket over there with the motor over there, down there, where the pull, we put it batik lamination. Batik is a cotton from Malaysia. I think from Indonesia also using the same thing. It's not silk, but it's batik. So we print it to become a prosthetic hand. Because you see a lot of the design coming from the overseas, coming from Europe, Americans. They put a tattoo design and then an American flag, eagle, and etc. I said, why not we come up with our own traditional way? So we put batik design over there, right? So that Malaysian or Indonesian can wear it as a as official clothes as well during the working days as well, right? All right. Talking about other kind of research, just now about 3D printing, before that about the sensors design, etc. This thing, for those who didn't know, these are the ways when we want to fabricate a prosthetics using a different kind of a plastics. All right. So we invest a lot, but then there's a lot of waste come from what we invest as well. We our we actually would like to help people. We get the donation, we make a prosthetic legs, we make a prosthetic hand, etc. But then of course, there's always some other issues as well. For example, this one. So this is known as a prosthetic waste. It's not a common plastic waste that we have from a mineral water bottle. No, this is different kind of a plastic. So for those who is working in the sustainability development field, for example, maybe these parts of your plan as well, uh, because this kind of a waste, not just from my university, my schools. I'm in Malaysia, the same condition, the same environment in JSPO, Jakarta School Prosthetic Orthotic, PSPO, Philippine School of Prosthetic and Orthotics, CSPO previously, now they changed the names already, Cambodian School of Prosthetic Orthotics. Before that, we have Myanmar School of Prosthetic Orthotic as well. We have Vietcot, Vietnam Prosthetic Orthotic as well. And then we have in SSTO just now. And then we have Pakistan as well. India, we have in Mobility India in Bangalore. And then we have Sri Lanka Prosthetic Authority as well. These kind of ways, not just my country, but I believe it is scattered throughout the entire Southeast Asia, and also worldwide as well. And up until today, there's no single 100% evidence on how we are able to recycle this thing. So please, all of you, newcomers, new designers, new ideas, as simple as oh, why don't you use this? Why do you use that? I know the policy. I know the policy maker. I know the ethical way. I know the law. I know the money. I know the account. Please help to settle this thing as well. All right, could be you are the generation to answer on how to recycle this thing. My research team, I come out with the publication as well, talking about the waste just now, recycling of a polyethylene TerraPlate waste. a review of technologies, roots, and also application, which is published in 3 years ago. Yes, you can read it whenever you want by searching the name over here. All right, next, last but not least, regarding the research, is actually the artificial intelligence. So you can see from this figure, people are talking about intelligence. We've seen a lot of movies, right? We've seen a lot of, like I mentioned just now, Avengers movie. What as we have Justice League, Spider-Man's movies. We have a lot of Star Wars, Star Trek, and etc. Right? Then we have an influence in the CSI, whatever series that we watch. So we've always been given this kind of a figure over here. Brain suddenly come out, human body suddenly appear, etc. We are heading to this. But now ask yourself, either we are ready to have a technology like this. Because when we have this kind of technologies, then we need to make sure we are ready to use it. But at this moment, we are not ready to use this. Although we keep on mentioning about artificial intelligence nowadays, but how do we go with this? We ourselves, is it enough just to have a TikTok account, Instagram account, share the stories, and etc.? Is it enough? Basically, no, because that is part of a sharing. What we need to have, how ready we are when we have all of this kind of a system. So every day you will live with the technologies. Like I mentioned just now, you wake up suddenly, Dr. Nas, today you are 90 kilogram. Okay, you are overweight. Please exercise, run 5 kilometers today so that you will reduce 5 kilogram by 5 p.m. today. Okay, so am I going to live with that? For me, I'm not ready because of my health, because of my age, etc. But things are happen to improve. So I need to improve myself to accept this kind of a thing, right? So how ready we are, ask yourself as well. Okay. So talking about artificial intelligence, understand yourself first. Talking about artificial intelligence as well in prosthetic orthotic field. Just now I mentioned about my team fabricate using sensor, using different kind of a plastic, using different kind of a material. But one day, my team no longer need to do anything. Why? Because all of you already provide me with the proper data. Average condition of a body, weight and height in Cambodia is 175 centimeter. Average of amputation is 75 percentage. Average of a people in Singapore is 90%, and average of a people in Jakarta, etc. So I just include the data into the system, enter the age, enter the height, enter the length, enter the weight, enter the amputed side, click enter button, automatic artificial intelligence design me a prosthetic legs. In 1 second, it will pop out the design of a prosthetic legs. Then automatically, you will have a prosthetic leg in front of you. So that is the condition of artificial intelligence in the prosthetics and orthotics. All right, that is about research. Okay, now I will go to the very last parts of my research of my lecture today. I'm just going to share a couple of interesting stories about what I have done throughout my research center. These are the people with the disabilities. You can see different kind of a famous figure. I think if you, of course, everyone know Luke Skywalker, all right, and then you know The Rock, Dwayne Johnson, and then you can see some others. It's actually John Hopkins, and some famous figure. I forget the name. The guy on the left bottom over there who is without any limb but able to swim and become motivators and etc. So these are some of the familiar faces who is using a prosthetics and orthotic throughout their entire life. So either they are congenital born or they are trauma because of the accident, etc. So you can see congenital, for example, people like the girl with the basketball. Okay, so even though provide with the prosthetic legs, she might refuse to use it because she already used wearing the ball rather than wearing the prosthetic legs. So that's why when you want to provide the prosthetics legs to the user, make sure it start from the day one so that he live with it rather than he need to accept it later on. It's the two different things, all right? So this is what my team did as a rep. We provide the education and also the rehabilitation. You can see people attending our clinics, people amputated, wheelchair user without hand, without legs, etc. We help them to give more information so that they can understand when they're using assistive devices. Some of them only receive a prosthetic legs, prosthetic hand from the hospital without a proper information. Maybe because of when they about to release from the hospital, they still with the trauma, etc. Right? So that's why they come back to our center, get more information, so that can help them to improve their annual daily life activities. Second, we also help to build the confidence among these people with disabilities. Uh, we, we guide them to become a motivator because some of them quite shy whenever want to share their experience. But actually, it's good to share their experience, although it is not good with a very not colorful journey of a life. But at least by sharing your experience to other people with disabilities, that can help to improve the situation, not only for the people with disabilities, but as well for us as well, so that we know that, oh, actually we have somehow make things wrong about you. It's not like you really want to have this thing, but because of we thought that you want to have that thing. As simple as that. Okay. For example, people without hand, they they cannot open a door with the one that have a circle bollard of a door access. No, they use this thing rather than this thing because they cannot pull it. All right. Okay, so this kind of as simple as that. All right. And the last one is that we conduct some of the sports activities as well. In Malaysia, it's known as sitting volleyball. I'm not sure with your country. So we play friendly um, sitting volleyball with the people with disabilities. And of course, they beat us, okay? Sitting, they perform very well compared to you when you are sitting and play volleyball. Try to do this, and maybe one day, if it happen that we can have a friendly among country versus country, we can try to have this. And of course, we have to train these people with disabilities enter the wheelchair basketball competition as well, and they become a champion as well. All right, four different story. The first one is related to this guy known as Mr. Hairuman. So you can see in 2010, these are the condition of the Mr. Hairuman. Okay, with the proper both side of a hand and also two side of a legs, but it happened that he got burned 75% of his body, 80% of his body, because he's plucking. He thought he's plucking a coconut tree, but actually he's plucking the power plant of electrical cable without noticing. And then it happened that 80%, 85% of his body burned, and it happened in 2010. So somehow, some way, nothing cannot be safe anymore. So the hospital has to cut both of his hand and one of his leg. No, both of his legs. Is it? No, one of his leg. And another leg you can see is actually totally burned as well, but he's wearing a orthosis. But then in 2017, our team discussed with Hairuman. We bring him forward. We help to assemble, fabricate his prosthetics, and then we involve him with our team. He motivate others and etc. He motivate others. Don't be like him. He's been waiting for prosthetic for too long because there's no one influence him to get the prosthetic hand, etc. He affect what going to be happen after this, etc. He's alone, etc. So he become a motivator, sharing his experience with others. This is case number one. Case number two, this young lady over here, known as Miss Raya, half body stroke. It happened, I think, somewhere in 2018 as well. So she's having a final exam in her higher school, and suddenly she collapsed because of a stroke. maybe because of the difficulties of the questions, it could happen. All right. So try not to stress yourself too much when you are in answering your final exam, etc. All right. Try to somehow heal, motivate yourself. Okay. So then she fell down, stroke, and after 2 years, she able to walk again, and she improving. He's moved. Miss Mazwin, you can see figure on the top right. 2010, her last prosthetic legs. We designed a new one back in 2018, and we finished with the prosthetic fitting. And the last one is Mr. Nazmi, age 26, motorcycle accident here in Malaysia. We have a lot of motorcycles as well. And then we help to improve his prosthetic legs as well. And he able to use the prosthetic, climb to Ankara mountain in Turkey. Alhamdulillah. And I heard he's trying to conquer the Everest in the next step. Maybe, inshallah. All right. I think that's all from my side. And of course, I can conclude that whatever we are doing right now is actually to sustain providing the information, guidance, and also become the advisor to people with disabilities, to become the consultant and educate and venturing empower the people with disabilities to a new level. And last but not least, I might say to all of you here, even we are with a different background, you can see based on the stories, based on the things that I share, there's at least 1% should come from yourself. How you want to improve the situation, no matter where you are, you can help to improve and make life better, especially here in Southeast Asia. That's all from me, Rifda and all. Thank you so much.
Okay,
I
thank
end
you
my
so much,
presentation.
Dr. Nasrul. Maybe you can
Um,
stop sharing. Um, Actually, before we jump into the next Q&A session, maybe as the participants have also aware that today Dr. Nasrul isn't feeling really well, so yet he still join us and do his presentation and share his valuable insight with us. So on behalf of the organizers, I truly send my gratitude and thank to Dr. Nasrul for giving your presentation today. Okay. So let's move to the wait. Let's move to the Q&A session. So, Dr. Nas, it was actually a very insightful presentation. It was mind-blowing. I never actually in my life joined a topic like this. So, me myself, I have several questions. Um, in many Asian countries, including Indonesia, our healthcare funding and facilities is still limited. So, how realistic you think that this research to be prioritized when even basic healthcare is still underfunded? That's my first question. And then the second one is, I do a little bit of research in Indonesia. The professionals in PNO, prosthetic and orthotics, is somehow very limited, the professionals. And those professionals are concentrated in Jakarta, Bandung, and urban center, Surabaya, or maybe Medan. So how do you think that research like this can be translated into actual benefits for people in rural areas?
Okay, two questions, Arifda.
Yes.
Yes, the first question is actually related with the field itself. All right. So basically, how do we put this? Yes, actually, we are actually really outnumbered. Not enough yet. That's why in Jakarta, for example, there's two schools running for this producing the prosthetists and orthotists every year. There's in Jakarta once, and I forget another place. There's another one as well. But but again, the population of in Indonesia is really high, and of course you need more. Same goes to other countries as well. I'm a part of the Southeast Asia Prosthetic Orthotic Schools, where each and every country have their own representative schools. So that's why I know about Cambodian, which is based in Phnom Penh. I know about Vietnam, they have a Vietcot. And then we have SSPO in Thailand, and of course we have Malaysia as well. And then we have Myanmar, but now they are helping by Cambodia as well. And this kind of a school, people in Pakistan, Sri Lanka, Mobility India, etc. Although we produce an average of like 50 to 100 yearly, it's still not enough to cater the problem that we have daily in whatever Southeast Asian needed nowadays. So that's why if you ask me, yes, the government, the Southeast Asia need to come up with a proper plan on how to do this. When I was in India, we have a couple of discussion as well. India have a lot of production in prosthetics orthotics, but there's none in Bhutan, there's none in Kazakhstan. These two countries as well need prosthetics orthotics. So that's why I believe that all of you over here, I know some of you is not related to the background, but the thing is that whatever I show over here play a key role in order to somehow helping the others. Because it could be our family members, it could be our siblings, it could be our father, mothers, it could be us, of course, one day as well, getting older, etc. So we need to have the proper assistive devices. Number two, talking about the research field. Yes, keep on improving. We need more funding, and the situation not just in Southeast Asia, but the situation similar in Europe countries as well. With that, talking about the prosthetic orthotic field, it is really minority, not just in Southeast Asia, in Asia, but as well in the European and also American as well. Because of we are not at the above par of a medical side. We are below than the rehabilitation side. So that's why the policies over there need to be bringing up a level. In the process of, like I mentioned before, I'm part of the International Society Prosthetic Orthotics. We are in the process of applying under the WHO to bring this thing forward. Because we are study from what had happened to Southeast Asia before, especially in Cambodia, who just among past war recently, right? So comparing to this kind of a situation, and then what we have in Gaza, what we have in the other country that having a war as well. So the need of a prosthetics is over there. All right. Hope I'm answering your questions.
Yeah, actually, yeah, I got you mean. So, the government role is very important in here because people with disabilities, people who needs this equipments also have the rights to have a proper and better quality of life, right?
Yes.
Okay. Maybe I want to call if there are any participants who want to ask directly to Dr. Nas. You can raise your hand. While waiting for that, this is a question from Liza Akhtar from Bangladesh. This person asks, since I come from an agricultural background, I'm curious to know what opportunities are there for for a student from non-medical fields like agriculture to contribute to prosthetic and orthotic research.
All right. Agriculture, as like you're talking about, different kind of things from the nature. If it is, yes, I would like to say like, for example, there's a prosthetic bamboo, if you would like to know. Prosthetic bamboo. So people are using bamboo to make a pylon for their prosthetics. All right. So this could come out from the agriculture as well. And then maybe from bamboo is famous in China. In Malaysia is a famous, but what could be other kind of a tree that can be used to make a prosthetic component from your own country? Right now, one of my research team using a kenaf. Kenaf is a fabric from the wood. So this kind of a thing. So we laminate with the prosthetic socket just now. So this is from the agriculture side. So these are the things that I said. Your agriculture, if you're talking about the type of a tree, wood, yes, we need some kind of a new wood, new kind of a tree, some sort of a bamboo or new kind of a, I don't know, type of a wood. In Malaysia, we have a jati, cengal, type of a different kind of a wood with a different kind of a mechanical testing that we can use as a pylon for a prosthetic foot. All right.
Oh, okay.
Okay,
Okay,
Rifda.
this is the other question from Asad Sahid. This person asks, how relate this webinar and research with my mathematics field in the future?
Mathematics. All right, mathematics. Like I mentioned just now. Okay. Let's say one day. Okay. Put it like this. There's a term known as anthropometry theorem. You can Google later on. Anthropometry theorem. Anthropometry theorem is come from people that design the aeroplane. Okay, when you're talking about the aeroplane, ship, aeroplane, okay, the size of a seat over there, they can measure what could be the size of your aeroplane. Is it Boeing 777 or 737? Just based from the chair itself. Okay. Now imagine you transfer the information as a human being. Me, myself, I have 180 centimeter of height. Centimeter or meter? Meter of height. Centimeter of height. All right. 180, 190. Sorry, 180. Okay. So let's say, without knowing me, are you able to know how long is my finger? Okay, what could be the length from my shoulder until my finger? What could be my length from my trunk until my hip, until my knee, until my foot, using a mathematical calculation? There's one term theorem known as anthropometry. Okay, this is related with the mathematical analysis. So from there, let's say people got amputated. One, he's lost both of his hands. So how he want to design the prosthetic hand without know the size of a prosthetic hand? He's been cut both of his legs, right? So how the prosthetic design want to know what could be the length of the legs, because of he don't know what could be uh, things to measure, because the both sides no longer exist. That's why when they know the exactly height before, so they can recalculate what could be the length of the prosthetic needed by the user. So you are from the mathematical side, try to calculate this based on the average of the size of people in your country. For example, that's what I said just now. If you Google what could be the statistical height of your male in your country, what could be the statistical height of a female in your country. From there, then you compare. Oh, Dr. Nas is 180, but most of the Malaysian is 165. So Dr. Nas must be much more taller than the other people. So then compare with the people from Pakistan, for example. They are from 185. So could be Dr. Nas can somehow use a prosthetic design from the Pakistan. All right. Hope that answered your question as well. Thank
Okay,
you.
so that every field, whether mathematics, whether engineering, even agriculture, can participate in this research, right? Because they bring new perspectives. Okay.
Yes.
This person, Mian Wahid Ahsan, maybe you want to ask directly, open mic, because the question it didn't finish type. I am from mechanical engineering. Although this field relate a lot with prosthetic and orthotic research, I also want to listen from Dr. Nurse. But what do you want to listen? Okay, maybe let's move to Islam Esperilla. What are the main challenge faced by postgraduate students in prosthetic and orthotic research in Malaysia?
I think Krislam Esperilla, based from your name, is it from Indonesia or from Philippines? I'm not sure. But however, if you ask me personally, I want to design prosthetics. Okay, it's not just about one person. You need to know about what could be the situation in other countries as well. So that's why I think Islam, its challenge will be to have a proper data from other countries as well. So this could be the challenge. For example, my height 180, but I don't know what could be the average in Indonesia, what could be the average in Brunei, what could be average in Nigeria, for example. So I don't know. So by knowing this, it could improve the situation of my own design. So I can come up with a design, Southeast Asia, XL, XLB, and then Nigeria, who came out with a large triple XL, etc. So this kind of a thing. Okay, thank you. From Malaysia, Islam.
Okay. I think last question. This is from Rina. She asked about do most of these projects end up being commercialized or applied in clinics, or do they mostly just stay as academic
Oh,
outputs?
we from University Malaya, because we are research university, and then we are abandoned with the University Malaya hospitals. So whatever project that we design, which is actually achieved to the standard that able to commercialize, then we will commercialize. So basically, we have our own spin-off company who will help to commercialize the materials and also the components, etc. So that's why we are right now in the process of before this, we keep on buying from overseas that bring the price of a prosthetic become higher. So now we want to reduce this kind of a thing. That's why we would like to become a production maker. So that's why I say, you are from agriculture, you provide with the new material, we come out with the new components. Things like this. So yes, we are doing this kind of a thing, and we are looking forward. To improve the condition.
Oh, okay. So, my personal question is, do the Malaysian government support the research? Or like, is there any funding from the
Yes.
Malaysian government?
Yes, not just Malaysian government, but we have a lot of international project related to prosthetics and orthotics as well. Not just because the project is really interest others on whatever the thing is, because we are improving human being, right? So yes, we have a local funding, we have international funding, we even have a worldwide funding as well. Depends on the condition. Yeah.
Okay. So, Asad Sahid said that he wants to join you in research with mathematics educational background as a master student in applied mathematics. Maybe he want to connect with you in LinkedIn.
Okay, later can have my LinkedIn is my name. You can just check it around, and I think Rifda, you can share with them later on my email as well. Yeah.
Okay. Maybe this is last question. This person sent through private message to me. Many research you showed are technically advanced, and how do you ensure they remain relevant to real needs of people with disabilities?
Okay, that's why we need to properly have people with disabilities be with us, because sometimes whatever we design too advanced, it cannot help to improve the need at the right now for the people with disabilities. So we will explain to them that this is the future direction, but whatever need today, we will help them as well. So this kind of a thing, because like I said, we design the advanced prosthetic hand, but then the people don't want to use it at all. They just said, no, I just want to hold the finger. I don't want this kind of too functioning, too complex prosthetic hands. So this kind of a thing. So the best is actually keep on communicate the user, the end user, because they are the one that want to use your design. So you cannot just simply like, oh, I want to design a tall building, but end of the day, no one go to the top of the building, right? I want to design of a fastest car in the world, but nobody can buy it at all. So this kind of a thing. So that's why keep on communicate with the end user is the best option. So that's why we, prosthetists, orthotists, we somehow fabricate everything when we discuss with the user. If it is not able to bring any benefit, we keep it freeze first until at the right time come.
Okay. Thank you so much, Dr. Nas. That question mark our end of our Q&A session. Actually, this person Samuel asked about if we could share the presentation slides here. Can I share it to them?
Yes, can, no problem.
Okay. After this, I will send. Our next session will be group photo. So thank you so much, Dr. Nas, for the answers, and thank you,
Sama-sama.
participants, for the questions. I want to ask to all the participants here to open your camera so we can take a picture together. Okay. Wait, while waiting for to open your camera, I will send the PPT. And then someone asked about Dr. Nas LinkedIn, right? Wait. have a moment. Okay, so this is Dr. Nas LinkedIn. If you want to connect, you can send him connection request. Okay, as the participant have opened the camera, let's I will do the screenshot. Okay, 1, 2, 3. Next slide. 1, 2, 3. Thank you so much, everyone. Thank you so much, Dr. Nas, for your time and sharing your valuable insights to all of us. After this, my colleague Sylvie will send the attendance link. And then, Dr. Nas, thank you so much for your time once again.
Thank
I'm
you so
sorry.
much, everyone. Thank you
On
so
behalf of the
much. See
participants,
you.
I said sorry if I do maybe mistakes or anything. Thank you so much.
Thank you, moderator and the doctor, for the wonderful presentation. Thank you, participant, for attending.